Hello, I am Astrid Bertrand. I'm a PhD student at the Polytechnic Institute of Paris, and I'll present a paper in which we implemented feature-based explanation to empower non-expert users in their financial decision-making. More precisely, the financial decision-making that we're studying is the moment when people choose to subscribe to a life insurance plan by accepting or rejecting a recommendation that is being proposed on a robo-advisor. This work was done in collaboration with the French regulators of financial services, and the study took place in France. The question that we studied here was how to explain why a specific life insurance contract is being proposed to a specific client. And this is important because it is legally required in Europe and France through the duty of information and advice in life insurance. It is required to formalize the reasons of the appropriateness of the proposed contract in relation to the client's needs. And this corresponds to feature-based type of explanations. And we're going to understand these regulations as having three underlying goals. The first one is to help the client understand the proposed contract. The second one is to help the client calibrate his trust about the recommendation. And the third one is to straighten the responsibility of insurance distributors by forcing them to have in writing the reasons for the recommendation. In this context, robo-advisors enable users to subscribe to life insurance fully online, and usually they provide only nebulous or generic explanations from what we can see on the markets, according to experts. Moreover, the robo-advisors are increasingly relying on AI, and since they provide real-time recommendations, they will also need real-time tools to provide explanations. So we questioned whether explainability and explanations provided through explainability methods could help meet those objectives of how the client understand and calibrate his reliance and trust in the recommendation. So to address this question, we developed an interface, a robo-advisor, based on the type of robo-advisors that we saw on the market. So our robo-advisor, called Robex for explainable robo-advisor, had the same user journey as current robo-advisors usually have. The first step is a profiling questionnaire where we collect the need of the client regarding his financial project. And in total, we collected 5 different inputs, notably risk aversion, knowledge, and experience. After this, the user can see a recommendation. So we created 5 fictional recommendations, and according to the client's expressed needs, we gave one of those 5 recommendations. And the specificity of Robex was to provide with those recommendations explanations, and we used SHAP to create those explanations. So we showed the impact of each of the client's inputs on the risk of the proposal. So we showed all the different inputs that led to more security and all the other client's inputs that led to be able to take more risk. We started the study with a qualitative pilot study to better understand the need for explanation as expressed by regulators on the one hand and novice users on the other hand. So we conducted semi-structured interviews with in total 11 participants, 6 regulators, 5 novice and users. And we analyzed the data through a thematic content analysis. And our results showed that regulators justify the need for explanations through the notion of risk. Because there is a risk, we really need to warn people, to notify them of the risk, and to show why there is this specific level of risk. Regulators also highlighted the fact that insurance distributors use tools that they themselves might not fully understand. They highlighted the relevance of feature-based explanations to help insurance distributors better understand their own tools. End user, on the other hand, highlight the need for more simplicity and the need for to avoid financial jargon. They also express their need to be engaged, sometimes expressing that the robo-advisor journey can be boring. Further, we conducted a quantitative study so as to compare how different types of representations of explanations help users understand the proposal and appropriately rely on the proposal. So we recruited 256 participants through a crowdsourcing platform, and we distributed the participants through a total of 8 different experimental conditions. We then measured whether they accepted or rejected the recommendation and their understanding, cognitive load, and trust in the recommendation. The different experimental conditions were regarding to the difference of explanation representation. So some participants had no explanation at all. This was the control condition. Other participants had an explanation, and there were 3 types of explanations. The first one, A, graphic static, is not interactive and provides a graphical type of explanations with factors that led to more security and factors that led to more risk. Graphic mutable enables people to mutate some of their inputs and to see the impact on the recommendation. Conversational formats had the same kind of content in the explanation, but provided the explanation in a conversational format. And further, participants were distributed in 2 big groups. One group that had a correct recommendation, so a recommendation that corresponded to their needs, and the other group had a bad recommendation, so either way too risky for them or not risky enough. What we found is that explanations do not help much in the calibration of trust and reliance, nor in the understanding of the proposal. So for instance, people that were in the control condition with no explanation at all were more likely than other groups to differentiate between a correct and an incorrect proposal. So if we see people in the conversational, so dialogic, graph mutable, and graph static were not always able to make a difference in terms of trust and reliance between a correct and an incorrect proposal. Further, we did not find any statistical difference in terms of comprehension on between the different conditions. And we also noticed that people that received conversational explanations were less likely to distrust an incorrect proposal and to reject an incorrect proposal than people who did not receive any explanation at all. So to sum up, we found that explanations based on features, on inputs features, are not always useful for the client's empowerment. And this has implications for other recommender systems and other legislations such as the GDPR. We also found that explanations are not always positive and not always neutral, but are sometimes harmful, which is the case of conversational explanations. Further, we have a hypothesis that people who received a conversational explanation relied on it more and trusted it more because they are more familiar with the format. So it might be the case. It might be also the case that graphical explanations are more concise, and so therefore more easier to read. However, some participants expressed their difficulty to read the graph format. Thank you for your attention.